Alright, a shade awning is being designed to cover a backyard patio. The clients want the two sides that are not attached to the home represented by segment XY and segment YZ to measure 12 feet and 10 feet respectively. The angle between the two sides that are not connected to the home is 35.1 degrees. How long will the side that is connected to the home, segment XZ, need to be to meet the client's request? Okay, so this is the side length that's connected to the home. Says to enter your answer as a number rounded to the nearest tenth if necessary. So if we were to decide if it was law of sines or law of cosines, law of sines, I'm looking for a pair of an angle with an one pair, which is the angle and its side length opposite it. So here's my angle, and I don't have the side length opposite it. So automatically it's not the law of sines. So we would go to law of cosines. So we're finding a side length in a non-right triangle, which we are doing. We have the angle opposite the side length you want to find the measure of, which we do have. We want to find the measure of x of little y, which is representing the segment of XZ, and we have the angle opposite it. So we have that requirement, and then we have the two side lengths that create the angle, which are 12 and 10. So we have that requirement as well. So now the side length we want to find is little y, and that's squared, and that equals the two side lengths that are creating the angle. So we have 12 squared plus 10 squared minus, and I'm going to put that in parentheses, 2 times 10 times, 2 times 12 times 10, it's those side lengths again, times cosine of the angle opposite the side length we want, which is 35.1 degrees. So then I would copy this and right there we have y being squared, we have 12 being squared, we have 10 being squared. So just make sure your squares copy over, or you could just type it all originally into here. And then this is going to simplify it for us. So it says to remove the parentheses, and then we have multiply the numbers 2 times 12 times 10, which gives us 240. So that's how they went from this 2 times 12 times 10 to minus 240 times cosine. So then 12 squared is equal to 144. So that's how they went from 12 squared to 144. 10 squared is equal to 100. So that's how they changed from 10 squared right here to 100. And then you add 144 and 100 to get 244, and so that's how they ended up with that number there. And they used the commutative property to just move this minus 240 cosine of 351 to the front and the 244 to the back, which is okay. And then since this is being squared, this says to square root the right sides and negative square root. So we have the y equals square root of negative 240 cosine of 35.1 degrees plus 244, or y equals negative square root of negative 240 cosine of 35.1 degrees plus 244. So then if we go up here, it gives us our decimal point right here. Since we're dealing with a length, we want the positive value, which is 6.90. This is rounded to the nearest tenth, so I would take the two numbers and say, is 90 closer to 90 or 100? And 90 is exactly 90, so it'll be 6.9, and that 0 in the 90 will drop down when you're rounded to the nearest tenth.